All right, so one thing Dalton said is that we can't destroy matter. We can only kind of change the way it's arranged. And so this is restated in the law of conservation of mass. And so basically what this states is that matter is neither created nor destroyed during a chemical reaction. So if you have 10 pounds of reactants, you have to have 10 pounds of products. You cannot have more or less. Matter is neither created nor destroyed in a chemical reaction. So for example, you can combine some sodium atoms with some chlorine atoms to form some sodium chloride, some table salt. And this stuff needs to be conserved. So this picture on the left demonstrates that. So you can see on the left, we have some molecules of sodium, in this case, 7.7 grams of them. And then we have some amount of chlorine gas, in this case, 11.9 grams. And then we can use it and combine it to form some sodium chloride, some table salt. And so the amount of mass that we had initially has to equal the amount of mass at the end. We do not create nor destroy matter. So that'll be an important topic when we get to stoichiometry. This is another example here. In this glass container, we've got some nice shiny copper, and then after a while it rusts to form copper 2 oxide. And so where is this kind of black stuff coming from? It's not being created or destroyed. It's just a recombination of the atoms that are already present. In this case, the copper atoms are combining with the oxygen atoms to form copper oxide. And so all matter has to be conserved. So there's some more laws that you should know about. There's the law of definite proportions. And the law of multiple proportions. And so basically what these two laws state is that since atoms exist as wholes, the ratios in reactions must come out to whole numbers. And so this stuff it's good. It does make sense. But I think for an intro level class, it kind of does more confusion than good. So I'm just going to tell you to see your book for further detail. If you'd like, we're not really going to touch on it too much. In my opinion, it confuses students more than it does help them. But if you're interested, check out your book. And then finally, another thing that you'll see in your book is the history of how the parts of the atom were discovered. If you'd like to read through that, go ahead, go through the book. We won't cover it in class, and I won't test you on anything like that. We're going to learn the science, not the history behind it.